Consider a signal xt having the Laplace transform xs, which is equal to log s plus 5 divided by s plus 6. The time domain signal xt is equal to. So we are required to calculate this time domain signal xt, and the Laplace transform of this signal is given in the question. There are 4 options and we need to choose the correct option. So let's see how we can solve this question. We are having the Laplace transform xs and we are required to calculate its corresponding time domain signal xt. So this case is the case of inverse Laplace transform. We are having the Laplace transform and we want the corresponding time domain signal. This means we need to perform the inverse Laplace transform. But whenever you are having this kind of situation, don't use the formula of inverse Laplace transform I gave you in the first lecture, because it will make the things complicated. So what can we do to obtain the time domain signal from the Laplace transform? We can simplify the Laplace transform and we will try to have the known Laplace transforms. This means we will try to simplify the given Laplace transform to the combination of known Laplace transforms, and from there we can easily obtain the corresponding time domain signal. This will be more clear when I will solve this question. We know xs is equal to log s plus 5 divided by s plus 6, and we also know we can write log m divided by n as log m minus log n. So using this I will write the Laplace transform xs equal to log s plus 5 minus log s plus 6. And now in the next step I will perform the differentiation with respect to s one time. So we will have dxs over ds on the left hand side, and on the right hand side we will have 1 over s plus 5, because differentiation of log s plus 5 with respect to s is equal to 1 over s plus 5. In the same way we will have 1 over s plus 6 as the derivative of log s plus 6. So this is what we are having. Now if you recall the differentiation in frequency property of Laplace transform, you will find if you multiply t raised to power n to a time domain signal xt having the Laplace transform xs, then the new Laplace transform of t power n xt will become n times derivative of xs with respect to s multiplied to minus 1 power n. Now we have already evaluated the result of dxs over ds. So if we put n equal to 1, we will have dxs over ds. So let's say n is equal to 1. This will give us t multiplied to xt as our time domain signal, and the corresponding Laplace transform will be minus dxs over ds. And we know dxs over ds is equal to 1 over s plus 5 minus 1 over s plus 6. So in the next step we will put value of dxs over ds. This will give us the Laplace transform of t xt equal to minus inside the bracket 1 over s plus 5 minus 1 over s plus 6. In the next step I will take this negative sign inside the bracket. So the Laplace transform of t xt will become 1 over s plus 6 minus 1 over s plus 5. Now it is very easy to find out the corresponding time domain signal of 1 over s plus 6 and 1 over s plus 5, because we know 1 over s is having the corresponding time domain signal as ut, And using the frequency shifting property, if we multiply e power minus at to ut, the Laplace transform will become 1 over s plus a. And if you look at 1 over s plus 6, you will find in place of a we are having 6. So the corresponding time domain signal will be ut multiplied to e power minus 6t. E power minus 6t. Similarly, 1 over s plus 5 will have the corresponding time domain signal as ut multiplied to e power minus 5t. And if you subtract e power minus 5t ut from e power minus 6t ut, you will get the time domain signal t multiplied to xt. And we are having the negative sign here because we are having the negative sign between the two Laplace transforms, and according to the linearity property, when the two Laplace transforms are subtracted, we are required to subtract the two time domain signals as well. But in the question, we are required to find signal xt, not txt. So to get signal xt, we will simply divide both the sides by t. So on left hand side we will have xt, and on the right hand side we will have 1 over t inside the bracket e power minus 6t. ut is common, so I will take it common. So we have e power minus 6t minus e power minus 5t multiplied to ut. And if you compare this with the given 4 options, you will find option A is the correct option. So this is all for this lecture. See you in the next one.